Hello and welcome to today's lesson. To get access to our starter pack files such as blueprints, technical primer PDFs, native CAD files, as well as exclusive master courses, join our community on Patreon at patreon.com/ArielCad3D. You'll find the link in the description below. In our previous lesson, we designed the central part, which is this one. This is just half of it. And now what we need to do is to finish the end part. So we've got this cylindrical part here, and as you can see, at nearing the end part, that's where we've got the attachment. One is for the U-bolt that is supporting this rear suspension system, the leaf springs that we also designed earlier in this playlist. So we've got two attached cylinders here where we bolt the U-bolts for the leaf springs. Then we also designed this assembly. If you haven't watched it, watch our previous videos. So for us to assemble it here, we are also going to attach it to this housing, as well as the other part is going to attach to the chassis. And we've also got this part here where these two halves are bolted together to endure the heavy loads that are experienced during the operation of the car. So let's first design this end cylinder here. We're going to create an access system here, and that is because that end part is inclined slightly at 3 degrees, so the wheels kind of slant like that. We start by creating a point using the center of a circle. We'll select this section. Then we're going to insert an axis system. And then we're going to rotate about the x-axis. We need to rotate about the x-axis so that the z can go 3 degrees towards this side. So you're going to right-click on x-axis and select rotation, then increase up to 3 degrees or type it. And in fact, you can see. Okay, so on this direction, it seems we should be going -3. Because I want it to slant this way, -3 degrees. Select OK. Then you sketch the ZX plane. Create 2 concentric circles. One is going to be 75 millimeters in diameter. That must be the mm that I just typed. 75. And the second one is going to be let's go with 50. Or even better, I can just, make it exactly the same as this one. By just projecting this curve and creating a circle that aligns with it. Let's see, that was 45, about 45, 46. Then we're going to create a pad. We will add 5 millimeters towards this side. So we have 5, and we'll have 40 in the other direction. This I think we made a mistake. 75 is supposed to be the radius, if I'm not wrong. Let me check that real quick. That is sketch 9. Okay, perfect. So 75 is the radius. So now we've got this part that is slightly slanted and aligns with the position of the wheels. So then we can create, we've got that part here that is bolted together. So I'm assuming these two are split in the middle. They are two halves. And for that, you will sketch this ZY axis of the original, the first axis system. I'm going to select this line to get the slope. Project it as a construction element. Go back to standard mode. Select profile. I can't tell if we projected. Oh yeah, I see it. Okay. So I need this line and the projected line. Did I select it? Projected line and this line. I need them to be parallel to each other. Not sure why I'm not getting that option, since it was a straight line. That's very strange. This line, this, and this one. Let me undo that first. And I'm thinking I'm going to project the baseline as well. Go back to standard element mode. But I also need this line and this line. That's very strange, but it's okay. I did align the bottom one with the top one, so we can have those like that. It's going to be all the same. So you need it to I'm pushing it all the way into this so that it's sort of like they blend together. And I'm just making an estimate. So just like these two, we need them to be two separate surfaces. So you're going to select a pad. Then limit 1 is going to be up to plane. And you're going to select this surface. I don't know if we can select, this is a rib. So perhaps that's very hard to select. Okay, so we can select it as a plane. Let's try to select it as a surface. Okay. Instead, then I can use dimensions. I already know it's 2 millimeters up to this point, and then this is 4. So I can just say 2 millimeters and -6. Yeah, that works. Oh, I understand why we're having problems. We used a different access system for these two sections. If you remember, we had one for this section, one for this section. So maybe I should have used each of those, but it's still fine. It's still okay. And I can try to align them. Maybe 0.5. If it doesn't work, I'll just transfer that sketch. And -7.5, no, 6.5. Okay, that's much better. And then I'm going to have it on the other side as well. So this side will be negative, and this side will just be 6.5. I'm going to reduce this height. I don't want it to be very prominent, to 20 millimeters. Okay. Then I'm going to have sketch the same ZY axis. Two holes. The radius is 2.5, so that it's 5 millimeter in diameter. Create a pocket. Say up to last. like so. To create the stiffener, we are going to add another axis system here, or we're going to click on this plane. The surface is a plane, and sketch. Then we are going to get a guideline of this surface by intersecting it with that surface. Intersect that plane. Oh, I don't know if it's this side. It is that section with this. So we get sort of that curve. And then I'm going to select this top part so that I can know the limits and project it as a 3D element. So we've got that point, and this point is going to be no construction element. Okay, that's fine. So now you can use profile. Let me zoom in. To this point. We can try using that. And then when we create a pad, we use, let's say, 4 millimeters. For direction, we use this edge so that it slopes along it. Reverse. Yeah, that's not bad. And we can create another one at this end. So I'm going to select the same sketch. Along the same direction. Can be even this curve. And can have limit 1 there and limit 2 right there. Let me adjust it a little bit. And I can choose to make it shorter by just adjusting sketch 12 so that this line, let me delete this line. I can choose to make it shorter like that. Let me see if I'm going to be able to. Yeah, I suspected that. Let's try breaking it. Again, I can't break it. Trim this line. Hold on, let me try that again. Trim this line up to this point. Perfect. Let's see. Yeah, I think that's much more reasonable. Not very large. And then we can try to select both of them and mirror using this ZY plane. That's fine. So we've got that section. And the other section that we have is where we are attaching. And I'm kind of reserved about placing that right now because I need the reference with the big, you know, the chassis. So maybe we'll have to open the chassis model and kind of measure the distance where we are assembling our friction dampers, and that will help us to position its attachment accurately here. So maybe I'll go and measure that distance, or I will show you, and then we'll come back and create the attachment. Okay, so locate where you created the chassis assembly. If not, don't worry, I'll just use the measurement and you can go along with it. Okay, so once you open the chassis assembly, you basically want to know the distance between the center and this part where you are attaching your friction dampers. So you can go to the side view and you see along this line, that's where you're going to, this is where the central wheel position is at, and you're attaching you see this part that you can see here. I believe this is the friction dampers. So your friction dampers are at this section and at this section. We've got two sections, okay, here and here. So you can, I believe this is a plane, but to be sure, you can just create 2 points. I will go to the ladder frame. You can just have 2 temporary points. Say on surface, and select this point. Don't know what happened. Let me try that once again. It might be because, let me go to the geometrical set so that I want the point to be white so that I can see it on surface. And I'm selecting this surface at this point. I can't see the point. I don't know why. That's very strange. Side view. Let me try on curve and just select, say, this curve. Now I can see the point. I don't know why it's not working on. Okay, I can create a reference point right there, or put it here in the middle right there, and then use that point to create 2 more points on surface, on this surface, using this point as reference. Okay, now I see it. So I'm saying we've got one section right there and another section about this point. So for the rear section, they are being attached on the side, right here on the side. There's an image that I showed you previously, or in the technical primer PDF, you can see it's being attached on the side, and then the other part is attached to the rear axle. And the rear axle is aligned with this wheel right here. So we're saying one part is being attached here and one part is being attached on that side, then another one here and another one on the side. So we've got two attachments, and I just want to make sure that these two have the same distance from the center. So I can measure between this plane, which is at the center, and this point. That's about 480. Then again from this plane, again 480. So this section is the same and it's 480. But remember, so 480 is where we begin to have that joint. Then we can call it 481. So I'm just going to go back to our section. Now for this section, remember that the distance between the center and this axis or this plane is 620. But you see our attachment needs to be at 480, and that's why we wanted to measure that, because if we create the attachment here, well, it's not going to align with, you know, with our chassis. But another thing to note is that you don't have, where is the chassis? It doesn't have to be completely at this section, like it doesn't have to start here. So we can have an attachment, you know, that is larger, and then the diameter goes down to where we are attaching those sections. I don't know if I can pull up an image and show you. Give me a minute. Let me see if I have so what I'm saying is, as you can see here, it doesn't have to start right at this section where we have the chassis. We can have a larger diameter, extending it, you know, pushing it outwards, and then a slimmer diameter where we are going to attach those friction dampers, so that we are pushing them towards the end of this differential connector, okay, or the differential housing, so that it's towards the end. And therefore we have some leverage here. We don't have to push it all the way. But then again, we won't have a very long, we don't want to have a very long attachment, because it's carrying a lot of loads. And you know, the longer you make it, the more it's prone now to have those fractures as it swings down, up and down. So we don't want this to be very, very long. So in that case, we can have about 500, because we said this point is 480. We can have 500, or we can have 510 or 20. Between 500 and 550 should be okay. All right. So I'm just going to delete this. Just undo and close my chassis. I don't want to save any changes. Okay. All right, so we can create now a plane. We're going to offset it from the ZX plane here at a distance of, let's try 530. And so you can see, oh, 550, but I don't want it to extrude too much. 550, and that is the position that we are going to place, that we are going to attach our friction dampers, that is. So in that case, remember, for our friction dampers, let me see if I can open the joint. We have friction damper assembly. We have this joint. This is the one that we are attaching. So we have this diameter here, which is very important to note. So the radius is 7.5. So that means it's 15 millimeter in diameter, and it is the same here. And the top one is attaching to the chassis. The bottom one is attaching now to this section that we are creating. Therefore, this length, which I believe is 20, if I'm not wrong, the distance between this edge and this edge, 20 millimeters. So we need to have a section here, a gap of 20, and another section there. We close this, and I'm going to sketch this. Once again, I'm going to select this surface. I want to intersect. I'm trying to determine the best position to attach those. Is it at the top or at the midsection? I'm going to intersect that surface with the plane. With that plane. And once again, this one, intersect with the plane. Okay. Because we are not going to create it very high up. It should be about this midsection. I'm also going to intersect this with the plane. Okay, so we have that full curve. And right about this section, that's where we are going to create our geometry. Which is typically a line, a tangent arc, okay, and this radius is 7.5 for the bolt section, and therefore it means the upper one should be larger. Radius, let's make it 10. Let's make this line horizontal. so that we have tangency at both these sections. So the lines, there's no need to add the dimensions here because, you know, they are controlled by this arc. Once we have that, we can trim this line. Hold on. I don't think that worked. Trim this line up to this point. Oh, I see. Okay. Then trim this line. Undo. I am messing it up. Let's try again. Trim this line up to this point. I don't know why it's making it. Okay. Trim this line up to this point. Okay, so the mistake was that this was selected. So 7.5 and 10. And then I might want to know the distance between the center, because this is the center of the wheel, and where I'm going to be attaching these friction dampers. That is going to help me when I'm creating the attachment, the other attachment on the chassis. So I'm going to just add a distance between these axes. So about 45. We can try 45 for now. And if later on we feel the need to change it, we can always change how far from the center is the attachment of the friction dampers. Okay, that's great. So again, we want it to start at this section, that is the joint. So this part is going to extrude towards this direction. Reverse, and if I make it normal, because it's going towards this direction, it's going to go into this section. So I don't know if I should extrude it a little bit more, because I really want it to be linear and it's cutting off this section. But either way, let's make this 20 millimeters. I do want it to be linear. I want it to be just straight, because the bolts are going to be attached in a straight line. I do want to leave a little bit of space, because when you're creating such a place, you want the spanner or whoever is attaching this bolt to not struggle a lot. So that distance from the center, we might have to add it. Let's add 10 millimeters. We did 45. Let's do 55. Okay. So we've got 55. And I think we made this very, very thick. $15 or $10. Yeah, 10 is fine. Then we are going to skip 20. So again, select pad using sketch 13. Limit 1 is going to be 20. And limit 2 is going to be negative 30. So that the joint will go in this section. Okay. So that's where we are going to attach our friction dampers. the last thing we have is where we are going to attach the U-bolts. We had another image here. So we have this one, and then we have where we are going to have the U-bolts, and that's on the bottom section. We have some on this side, some on that side. We are going to do just a simple cylinder. Sketch the ZY. We are going to create, and again this should align with where we have those leaf springs. So again we're going to have to measure that. But before we do that, we're going to have two sections here. Like so, and then they are going to contain which are each, don't know if we've made them too large. Let's make this one 15 and this one 7.5. $15. $7.5. Let's create an axis here to make sure they are both coincident with the axis. Am I selecting the point? The same on this side. Okay, that's already coincident. And we are also going to have a distance between the two centers. So in the next episode, in the next lesson, we're going to measure that distance, because that distance is the size of the plate which we did earlier on. So we need to know that distance of the U-bolt, and also confirm these diameters. So we will do that in our next episode. We'll finish this up, and we also mirror our object in the other direction.